Okay, so in this video we want to look at how to convert complex numbers into polar form. So this is where we express a complex number in terms of its modulus or its length and its argument or angle. So usually we write a complex number in Cartesian form. So this is what we mean by Cartesian form. So I have x plus iy, and we want to instead write it as r e to the I theta. Here r is the modulus of the complex number, and this is just the square root of the sum of the squares of the real and imaginary components. The angle is given by the inverse tangent of the imaginary part over the real part. And you can see this in the following way. Suppose that I write my complex number on the Argand diagram. So maybe here's my z. So then I have, here's my x, here's my y. And what I instead want to do is look at it in terms of this radius or this modulus and in terms of this angle theta. So what we have here is that by Pythagoras Theorem, r squared is x squared plus y squared. So in particular, r is the square root of x squared plus y squared. And this theta is, so tan theta is opposite over adjacent, which is y over x. And so theta is just arctan of that. Okay, so let's go through some examples. So here we have z equals 4 plus 4i. We need to first calculate the modulus. So that's the square root of 4 squared plus 4 squared, which is the square root of 32. And we can write 32 as 16 times 2. So the modulus is 4 square root of 2. And to find the argument, so let me just make this notation explicit. This is the modulus, and this is the argument. So the argument is arctan of 4 over 4, which is arctan of 1, which is pi on 4. Notice that it's not 5 pi on 4 or anything like that, because 4 plus 4i lives in this quadrant, and so we have pi over 4. Tan is also 1 in this quadrant, but this would have a negative imaginary part and a negative real part. So we're in this region here. Okay, so if we want to express z equals 4 plus 4i in polar form, all we need to do is write z is 4 square root of 2 e to the I pi on 4. Okay, next example. Here we have 2 square root of 3 plus 2i. So the modulus is the square root of 2 root 3 squared plus 2 squared, and 2 squared is 4 times 3 plus 4. So we have the square root of 16, and the square root of 16 is 4. Now the argument is arctan of 2 over 2 root 3, which is arctan of 1 over root 3. And if we want to figure out what arctan is, we draw our triangle. We go 1, 2, root 3, pi on 3, pi on 6. And so opposite over adjacent, so this is pi on 6. And so in polar form, we have that z is 4 e to the I pi on 6. Okay, now let's see if we can go the other way. So we want to convert 2 e to the I pi on 3 into Cartesian form. So here we need to use the relation that r e to the I theta, so this is Euler's formula, is r cos theta plus r I sine theta. So this is called Euler's formula. And so what we see is that 2 e to the I pi on 3 is 2 times cos pi on 3 plus 2I sine pi on 3. Now to evaluate cos pi on 3 and sine pi on 3, I'm again going to use my triangle, 1, 2, root 3, pi on 3, pi on 6. This triangle is very easy to remember because you just go 1, 2, 3 and then just put a square root on the third term. And to remember that pi on 6 goes here, you just go 6 is big, 3 is big, and so I'm going to put them together. That's all I ever used to remember it, and I've remembered it for years. So cos pi on 3, cos is adjacent over hypotenuse, so cos pi on 3 is 1/2. So I have 2 times 1/2. Then 2I times sine pi on 3, sine is opposite over hypotenuse, so I've got root 3 on 2. And what I end up with is 1 plus root 3I. And that's it. If you want to, since practice is so important, be sure to check the video description for the tute notes where we have practice problems and the cheat notes for fully worked solutions. If you liked the video, be sure to hit the like button, and if you want to see more content like this, hit the subscribe button. Thanks guys, I'll see you in the next video.